Hi, this is the first of 3 little videos on solving trig equations. These are the really simple examples that you did in grade 11, but I think it's worthwhile just doing them for revision purposes. In this example over here, we have to get the sine of the angle, that whole ugly bracket, on its own. So we're going to write 2 sine of that bracket is equal to -1. And then I'm going to divide both sides by the 2. So we get sine of 2x plus 40 is equal to -1/2. We make use of arcsine, and arcsine of -1/2 is going to be minus 30 degrees. So we get that 2x plus 40 is equal to minus 30 plus k 360, or we get that 2x plus 40, let's just divide our page, is equal to 180 minus 30, 210 plus k 360. I still need to get the x on its own, so here 2x is going to equal minus 70 plus k 360, so x will equal minus 35 plus k times 360 divided by 2, 180. On this side over here, 2x is going to equal 210 minus 40, which is 170 plus k 360. I'm then going to divide through on both sides by 2x, so x is going to equal 85 plus k 180. And as usual, we're going to say at least one place in the sum that k is an element of the set of integers. This example over here, sine x equals 3 cos x. It's really important to realize that in this case you cannot use cofunctions because of that 3. So I'm just going to say sine x divided by cos x is equal to 3. Tan of x is equal to 3. So x is equal to arctan of 3, which is 71,57 plus k 180. K is an element of the set of integers. Now in this case, cos and sine, we can use our cofunctions because there is nothing in front of either the cos or the sine. So I can say cos of 2x is equal to, take the cofunction of sine, which is cos, take the complementary angle of x plus 30, which is 90 minus x plus 30. All right, this means that 2x is equal to plus or minus 90 minus x minus 30. You must split that up and solve 2 separate equations. You can't solve plus minus that bracket in one go. So the 2 equations are 2x is equal to 60 minus x plus k 360, or 2x is equal to minus 60 minus x plus k 360. This is going to give me 3x is equal to 60 plus k 360. X is going to equal 20 plus k 120. On this side over here, I'm going to get that 2x is equal to minus 60 plus x plus k 360. X is therefore going to equal minus 60 plus k 360. Again, k is going to be an element of the set of integers. This last example is different to the previous one because there's a minus in front of the sign. We are going to use the trig identity that says sine of minus theta is equal to minus sine theta. Please remember that cos of minus theta is equal to cos theta. So it's really important that we always use that minus in front of the sine, never in front of the cos. So here I'm going to get that cos of x minus 30 is going to be equal to sine of minus 2x plus 10. Now that I've got rid of the minus in front of the sign, now I'm going to use my COCO rule. Take the co-function and the complementary angle. So I land up with cos of x minus 30 is equal to co-function of sine, complementary angle. So I'm going to say it's 90 minus 2x plus 10. Okay, when I simplify that, I'm going to get that cos of x minus 30 is equal to cos of 100 plus 2x. This is going to tell me, let me just do a line down there, this is going to tell me that x minus 30 is either equal to 100 plus 2x or 100 minus 2x. I'm just going to write the two, one underneath the other here. 100 plus 2x plus k360. Or the other possibility is that x minus 30 is equal to minus 100 plus 2x plus k360. And each one of those needs to be solved. So here 2x goes over to the side, x minus 2x becomes minus x is equal to 100 plus 30, 130 plus k360. So x is just equal to minus 130 minus k360. On this side, x minus 30 is equal to minus 100 minus 2x plus k360. In other words, 3x is going to equal minus 100 plus 30, which is minus 70, plus k360. I'm going to divide both sides by 3, and x is going to equal minus 23,33 plus k120. Again, k is an element of the set of integers. Thank you.